So we want to take the derivative of y equals the natural log of 2 times e to the negative t power times sine of t. So I could take the derivative of this. I would have to, if I just went through and took the derivative as it's written like right now, I'd have to use the chain rule. My inner function, when I take the derivative of the inner function, I would have to use the product rule. And within that product rule, when I take the derivative of e, I would have to use the chain rule again. And so there's a lot going on in there. And so if we use rules of logs, we can rewrite this. Notice there's multiplication. And if we have a log with multiplication, we can break it up as a sum of logs. So we can technically break down this as the natural log of 2 plus the natural log of e to the negative t plus the natural log of sine of t. And so just kind of a reminder, if we had y equals the natural log of some function g of x, which in the case we do here, natural log of sine of t, except that would be g of t. The derivative of that was equal to 1 over what we were taking the natural log of, which was g of x, times the inside, which was g prime of x. So we could write it as g prime of x over g of x. Okay, so let's take the derivative of y now. Well, what's the derivative of a constant? Derivative of a constant is 0. And that's all the natural log of 2 is. That's what exponent we would raise e to get back 2. So this is 0. Plus, well, before we take the derivative of the natural log of e of t, maybe we can rewrite that. Isn't the natural log of e to the negative t? Well, this is saying e to what power would give us back e to the negative t. Well, I'd raise e to the negative t power to get back e to the negative t. So that result is just negative t. So if I take the derivative of negative t, that's just negative 1 plus the derivative of the natural log of sine of t. So using our rule, this is plus 1 over what we're taking the natural log of, which is sine of t, times the derivative of sine of t. So derivative of sine of t, remember, was positive cosine of t. So I can clean this up a little bit if I wanted to. This is the same thing as negative 1 plus, well, cosine of t over sine of t, I could rewrite that as a single trig function, and cosine over sine is cotangent t. So a lot of times rewriting the function that we're going to need to take the derivative of in a different way can help us to find the derivative. And we've been seeing that all the way through this chapter. Let's look at one which we have the following. Oops. I'm trying to move my screen up, but that doesn't happen with this program. So let me just see. So we want to use logarithmic differentiation to find the derivative of this y equals parentheses x plus 1 in parentheses that's raised to the x power. So we can take the natural log or log of both sides. It's so much easier to take the natural log, as we found, because it's just easier when we're taking the derivative than a log based other something else. So do something to one side of the equation, we can do it to the other side. And so we have the natural log of y is equal to the natural log of x plus 1 all raised to the x power. Now let's use our rules of logs. We know that we can bring our exponent down front. And so bringing our exponent down front, we have that the natural log of y is equal to x times the natural log of x plus 1. We want to find the derivative of y, and so now we can differentiate both sides. And so we're going to take the derivative of both sides of our equation. So d dx, do something to one side, do it to the other side. But when we do this derivative on the right-hand side, we're going to have to use that product rule. Derivative of natural log of y, we're going to use the chain rule because y is a function of x. And so we're going to take the derivative of the natural log of y, and then we're going to just tack on dy dx. So derivative of natural log of y, that's just 1 over y times dy dx is equal to, so product rule, we have to take the derivative of the first, which is derivative of x is 1, times the second, natural log of x plus 1, plus the first, x, times the derivative of the natural log of x plus 1. So that's just 1 over the inner piece, x plus 1, times the derivative of the inner piece. Derivative of x plus 1 is 1 times 1. Those are times. So this is equal to, let's clean this up a little bit. And at the same time, we want just what the derivative of y is with respect to x. We don't want that times 1 over y. And so we can clear that y on the one side by multiplying both sides of our equation by y. So we would get the derivative here, dy dx, on the left-hand side is equal to, I'm going to have brackets, natural log of x plus 1, plus, I can rewrite this as one fraction, x all over x plus 1, all times y. We want this function just in terms of x. So we don't want y here, but we know y is just x plus 1 raised to the x power. And so using logarithmic differentiation, we were able to find the derivative of that function. Okay, so let me stop.